Hello friends, welcome back. Today we're going to do a huge difficult problem. I've run across this one and it took me forever to figure this one out. And so yeah, here we go. This is the last one on our JavaScript algorithm data structure project. And this will wrap up our JavaScript algorithms and data structure certification, which is very exciting. So let's get into the cash register. I'm going to start by expanding this and making this a little bit more legible. I just like to make everything, whenever I'm working on software projects, I like to make them all very explicit. And so I just like to make everything very easy to read. So I'm kind of set it up like this. Here we've got the stuff. So design a cash register drawer function, cash register, that accepts purchase price as the first argument, price. So here it's 19.5. The payment as the second argument. So here's the cash. So this is like the price of something you bought. Say you got 1950 sunglasses, you gave them a $20 bill, and then the cash in drawer, the CID, as a third argument. So that CID is this array, which is a pretty long array of units of money. It's a two-dimensional array listing available currency. So how much currency is in the cash register? The check cash register function should always return an object with a status key and a change key. So we want to return status of insufficient funds if the cash in drawer is less than the change due, or if you cannot return the exact change. And we want to return a status of closed and a change with the CID with cash in drawer as the value of the key change if it is equal to the change due. Otherwise, return status open. And then the change with the change due in coins and bills sorted from highest to lowest order as the value of the change key. And so here they've got just a listing of currency types for US bills. So penny is equal to 0.01, dollar is equal to 1, and so forth. So below here we've got the example of a cash and drawer array, which it looks like is the one that's actually here. So this is our CID. We could actually take this out and make a variable. So let CID equal this, and then pass in CID here. And yeah, that makes it so it's just a little bit more explicit. In my opinion, it makes it a little bit easier. And we can say let result is equal to this one, and we console.log the result. So now we can kind of see what's happening. Okay, so the first thing that we want to do is add our denominations. But JavaScript has a thing that's tricky. I had to learn this the hard way when I was programming. But essentially, like, let's do an example. So essentially what I'm saying is that JavaScript's bad at math. This is the reason people say learn Python or Ruby rather than JavaScript. Because if you have like 2.05 minus 0.05, it's a very simple problem, right? It should be 2, but it renders out to 1.999998. This is a huge problem for working with this project. So we don't want to be using these floating point. These are called float numbers, whereas integers are simple integers like 2. So one way we could deal with this is we could say math.ceiling. So we just round everything up to this, and that would get us the right answers. But we're still dealing with this kind of random variable when using float integers. So the better thing to do would be just to multiply everything by 100 and then skip the whole process of converting it. If we just deal in units of 1,000, so 100s are worth 10. 100 is actually 10,000, and a penny is actually with 1. Then we're in better shape. So let's start it off by making the denominations. And we can make this a constant. And I'm going to call it denominations. And then we're going to set this equal to an array. And in order to make this kind of quick, I'm going to copy this guy. And instead of making it like that, I'm going to just go 1. A nickel is worth 5 cents. A dime is worth 10 cents. A quarter is worth 25 cents. A 1 is worth 100 cents. A 5 is worth 500 cents. A 10 is worth 1,000 cents. A 20 is worth 2,000 cents. and then a 100 is worth 10,000 cents. Right? So if we were to console.log up here, the denominations at 0.0, we would get our penny. If we were to do it at 1, we see our nickels worth 5 cents, 2, dimes worth 10 cents, 3. So now we have this object which just holds the value of bills. Okay, so now what we want to do is start working with this stuff. I'm actually not going to use anything. I'm not going to use this at all. Let's just start off with some simple things. So we know that our cash minus our price is going to be the amount to return, right? So let's say let amount to return, and we'll set that equal to price minus cash. So now if I console.log the amount to return, we'll see that we're getting negative 0.05. So I actually messed this up. I should, because we're given a $20 bill and we need to pay, and the thing costs $19.50, we need to return them 50 cents. So we want to say cash minus price. And here we're getting this decimal thing again. We don't want the decimal because we're going to be working with, pennies. So I'm going to say cash minus price times 100. Cool. So then we get 50. I wonder if this is like if it was 1905 and they gave us back 1910. Okay. So you see, when I do it like this, it totally throws us off and it gives us this giant floating point decimal. So I think the better thing to do, instead of putting the 1,000 on the outside, we can just multiply it in here. That doesn't even work. Interesting. Okay. So maybe we want to go math.ceil. I think you can do math.round. Cool, that gets us there. And so, yeah, let's do it with both numbers just in case we get some wacky ones. Now, let's see. I want to shift this one back to the way that it was. So 19.5, and they give us 20. And so does this get us right? Yeah, we want to pass 50, pennies back to them in different denomination amounts. So our amount to return is set. And then I'm going to create two objects with, so I'm going to say I'm going to say cash on hand, which is going to be equal to an object. And we're going to turn this into an object based on the CID that's being passed in. And then we're going to also have let cash to give. And we'll set that as a variable as well. So this is going to be equal to, right now I'm creating an object because here we want to be returning, we want to return the change, but I'm going to make it an object initially, and then we're going to pass it back as we're going to convert it back into an array in the future. And so, yeah, there's that. So what we want to do now is turn our CID, which is being passed into here. If we log our CID right here, you see we're getting passed in this object. So our CID, it's being passed in as the third argument is here, and it's pennies. And so what I want to do is convert this to our cash on hand. So what I want to do is I'm going to convert all the elements of the CID and pass them in as key value pairs for the cash on hand. So the CID is an array. So I'm going to go CID.forEach, and then we're going to say, I'm going to do long and then a long JavaScript denomination. I'm going to do long JavaScript initially, and then we'll refactor at the end. And so if I were to, instead of console logging here, I'm getting just undefined. Let's console.log in the denomination. So you see, if I console log in here, you're seeing that it's passing the denomination in here. And so if you go denomination at position 0, we're getting penny, and then we're getting the amount. And so what I want to say is I'm going to say our cash on hand for the denomination as 0. You see the denomination is 0, so we're saying cash on hand and then the key value of penny, and we're going to set that equal to the denomination at position 1. And so, yeah, that's denomination in position 0 is the string of the name, and at position 1, it's the thing. And then so here, now if I were to console.log our cash on hand, you'll see that we have an object with all of our key value pairs for our cash on hand. So this tells us that our cash on hand, and it gives us the amounts in an object format, which is much more useful than doing it with any other way. So our cash on hand now is ready to be used. Okay, so now let's think about this kind of in depth. We have, if I were to console.log our amount to return, we get 50, right? I'm going to comment out this guy for now. So our amount to return is 50. What we want to start doing is doing the denominations backwards, right? So we have our cash on hand. Well, actually we could go, so if we go denominations at say position 0, we're going to get a penny, right? There's 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 bills, right? 100 is right there. So what we want to go is denominations at 8, and then say, does 8 go into 50? So denominations at 8 at position 1, right? So that gives us the 1,000, right? So the denominations, here's the 100 bill, the bill name, and then there's the bill value, right? So the value is at position 1, and at position 0, it's the name of the bill. Okay, so what we want to do is iterate down 8, 7, 6, 5, 4, 3, 1. Say, is 100, is the 100 at position 1, so the value, is this less than that? Well, we know here it's not, so we're going to go 7, 2,000 it's not, 6, 1,000 it's not, and 5, no, 4. See, that's a $1 bill, 3, 25. So yeah, 25 is less than 50, so therefore we can add a quarter to our cash on hand object, right? And so that's what we want to do. So I'm going to set up a while loop, and while loops use index because we want to use a while loop to iterate back through here. So let's let our index equal the denominations dot length. And then we say while index is greater than or equal to 0, we're going to do something, right? And then we're going to say index minus equals 1. So we're going to reduce index by 1. So now if we were to console.log index in here, we're going to see that it iterates down. It gives us 9, 8, 7, 4, 3, 2, 1. And denominations, so then we can say denominations at position of index. Now we're iterating down. Okay, and so I'm getting undefined initially, so I want to make denominations.length minus 1. So that starts us off at 8 rather than 9. And so now we iterate down. And so our idea here is what we want to do is we want to keep iterating through this loop while the index is here. So 100 here, we can do our denominations at index at point 1. So now we're getting this number, and then we can say our amount to return as well. If I put this in here, we see that it's here. So now we can make a differentiation on this. So what we can do is say if denominations at index point 1 is less than this guy, then we can use this denomination. I hope that makes sense. So if our amount of our denominations at index here is minus our amount to return is greater than 0, then we can console.log our denomination at index. Let's just do that for now. And we'll get rid of this console log. Okay, and so this isn't working. I think I've actually got these switched. because we want to say the amount to return. Let me hear. I'm going to console.log the amount to return, and then our denominations. And then get rid of this console log. Okay, so yeah, amount to return minus denominations. So I'm gonna call I'm gonna actually make a variable here. So I'm gonna say let denomination equal the denominations at position index. And so now I don't have to keep writing denominations index each time. And so I can just write this one out to be denomination at position. Well, I'm just going to call it, for the console log, I'm just going to print it out here. So is 100 going to be for 50? So 50 minus 100, is that greater than 0? No. So we're not actually going to log that out. And so I actually had those switched. So now I can just, in here, I can just write denomination at position 1, right? Denomination at position 1. And so let's get rid of this console log and read this console log. Now this is strange to me. It shouldn't be denomination at position 1 minus the amount to return is greater than 0. So let's console log here. And then I'm going to put this guy in here. Okay, so I've got these switched. So this should actually be on this side. Oops. Amount to return minus the denomination at position 1. And if we console log this, this should give us, negative answers. It's negative numbers all the way down to here. And then once we hit the 25, we're saying, 50 minus 25 is greater than 0. That returns true. So that's the first time. So we get the quarter. And that's the one that we want. So we're saying the quarter is the best unit of change to start with here. And so this is great. Let's get rid of this guy now, because now we can see what's happening. We're passing it in. So because we've got the denomination properly working here, we can continue our process. So what we see that a quarter comes in first. Now for this specific example, we actually want to return 2 quarters, right? So we could sort of start decrementing and adding to the cash. Well, let's just do our initial one. We know we want to say cash to give. We want to add it to the cash to give. So we can say the cash to give at denomination, the cash to give, because this is an object. So we're going to say the key for that is going to be the denomination at position 0. And we want to set this, right? And so this is going to be a quarter right now. And so we're saying the key is quarter, and then the value will be the denomination at position 1. And so if we were to console.log the cash to give object, the entire object, I'll get rid of this console log. Then we've got our quarter. And so what's happening right now is actually pretty cool. You can see that we're going down the line. We added a quarter, a dime, and a nickel. So we've got 25, 35, 50 cents, and then we've 51 cents, and then we're quitting. So what's happening? Well, we're not staying on quarter. We should stick on quarter, right? So I think that we kind of need to do the same thing. We want to iterate through this object again. So what we need to do is... Okay, well, actually, instead of setting this to the denomination at position 1, let's just set it to 0. So now our cash to give, what we're doing is just we're adding that here, because what we want to make sure that we have enough of the money on hand before we add it to the cash to give element, right? So I want to create another while loop. And within this while loop, I'm going to say... So here we want to make sure that we have more cash on hand than we need. So we want to make sure we have more than 2 quarters. So yeah, actually I'm just going to console this out for a second and just make a point here. So cash to give is equal to that. Now our cash to give, but our cash on hand our cash on hand. We want to make sure our cash on hand is greater. So we want to make sure we have more quarters than we need. Here we've got 425. That means we've got a bunch of quarters. And so yeah, I actually need to make this times 100 because we've got 4.25, and we want to make this math.round our denomination over here. So yeah, you see I had 10.1, or I had 1.01 pennies, and now we've got this many. So we've got 425 worth of quarters. That's our cash on hand for quarters. Well, actually, we can use our denomination now, right? For our denomination at position 0. So this gives us our quarters, right? Our denomination position. So our cash on hand in quarters is 425 at this point. And so we want to make sure our cash on is greater than 0, because we want to make sure that we can give this amount, right? Is greater than 0. So this should say true, because we're having enough the whole time. And so I'm going to copy this into here. And then so while that's true, then we keep doing this situation. So yeah, what do we want to do here? We want to decrement our cash on hand. Our cash on hand at denomination of 0 minus equals denomination at 0, but at the value, the denomination at 1. Cash on hand. So, okay, so what's happening now is we're getting an infinite loop. Our cash on hand at denomination 0, let's say, okay, we're getting an infinite loop, invalid. Left-hand side argument expression for denomination 0. Oh, I've got an extra thing there. Okay, cool. So now we're doing that. Let's console.log our cash on hand at denomination of 0.0. Cash on hand at our denomination. So yeah, well, this is cool. What's happening is, well, we're creating a loop which is causing us to break out. So 425, we start off with 425 cents worth of quarters, and then we get 400 and 375. But we keep going. We're not breaking out of this loop. So we want to make an additional statement in here. So what do we want to say? While that is true, and we want to say, because here what's happening, we're getting 425. What happens if we add into the amount to return? So I'm logging the amount to return. So amount to return is staying the same. So we also want to decrement the amount to return. We want to make that minus equal to the same denomination value. So we subtract that by 25. So then we're getting 50, 25. And then, yeah, it's getting crazy still. So what's going on here? We're decrementing 425 from that, and then we're saying now we only owe 25 cents because we've taken 25 cents out of the register, and then we've done 0. So we want to make it so that these only execute. Well, let's stick with this one first. So while the cash on hand and the amount to return is greater than 0. So then we're only doing it twice here, right? Which is great. And so, yeah, this is good. I'm going to get rid of this console log now. And let's say down here, our amount to return, we've got 0 and 25. Let's see what is our amount to return. Cash on hand. Oh, we're decrementing the cash on hand, but we also want to add it to the cash to give. So because we've already set the cash to give at denomination here, we want to add, so we say plus equals the denomination value. So we want to add that to this. So we set the key up here, but then we're actually setting the amount with our second iteration. So yeah, if you see our cash on hand, instead of this one, we're going to say cash to give. So first we owe 50. Yeah. Oh, this is cool. So our amount to return equals 50. Our cash to give is this object that's incrementing up. Okay, so now we seem to be working on well. Let's see what happens if we console.log at the bottom here. Let's get rid of this console log, and then down at the bottom, our amount to return. Our amount to return is 0, so that's great. And so what about our cash to give? Our cash to give is an object with the right amount of cash in it, so that's great. We want to be able to, so let's say, so if our amount to give, if our amount to return, if that's equal to 0, so if the amount to return is equal to 0, which in this case it is, then we want to return, here we want to return an object, right, with the status of quarters, right? But obviously we don't want to just return, not obviously, but instead of having our change be equal to that, we want to make it into an object. However, if I console log our cash to give here, you'll see that it's in this format, and we need to change that. We need to format that as the way that we want to return it. So right now it's just quarter, but we know that oftentimes in this there's going to be a lot more. So how can we do that? Well, one thing that we can do, we could say object dot keys, and then pass this guy into the object dot keys. If we get that, then we have a thing right here. So this it gives us an array. So if we say for each element of that array, so object dot keys dot map, and then we have, I'm gonna just do long elements now, money type. So if we do the money type, if we were to console.log money type, then we're getting quarter, and we can add this to a object, right? We can or to an array. So we'll say we're gonna say let our change array equal this array, and then our array is going to be filled with our money type is a quarter, and then if we want to see how much we do there, we go cash to give at position of money type. So then we've got quarters and 50, and what we want to do is pass in to an array value pair, right? So what we want to say is our change array. We're going to push onto that array our money type and our amount, like that. Okay, so if we get rid of this console log and we were to console log our change array down here, we'll see that it's quarters and 50. But there's actually a problem here because it's 50. We want it to not be 50. We want it to be 0.50, right? Because we're passing this back. So we want to divide it by 100. So now we're getting quarters at 0.0. So now instead of passing it in hard-coded like this, we're just going to pass in our change array here. And this should pass this second test. So let's run it and see what happens. Status open, change array. Should return status open, change array. I wonder what happens if I console log here. Console.log our result. Status open, change quarters. Change is equal to quarter. Okay, so what's happening is the change it needs to be an element like that. And so what we're doing is we're pushing in the quarter, but it actually needs to be in its own separate array element. So we need to bracket it within an array like that. And if we run the test now, this second one should pass. Okay, great. So the second one's passing and these other ones aren't passing. Let's get rid of this console log now. And then one thing I'm noticing that the sort of default value is just to have insufficient funds. That's whenever anything is not working. So let's just say if the amount to return isn't equal to 0, but we can just, we can just return insufficient funds at the end if nothing really works out. If we run the test, I bet that'll pass a bunch of things because we just have a default thing of passing out insufficient funds. And so now we need to deal with the other two edge cases. So this guy should return a different sort of situation. So if I bring it down here and I pass this guy into here, and I need to make this the CID, make this the CID. So what I'm doing here is I'm just forming up the next test to see if we can make it pass. If we console log the result, we get the insufficient funds here. So there's something happening in this example in which we have we're given a $100 bill for something that costs $3.26. And so we should have a status of open, and then our 20, 10, 5, 1 quarter, dime, penny should look like that. But that's not what's happening. So let's look into it. I think if we come up here and we console.log our cash to give, let's see what it looks like at the end of this. So we have 20 has 6,000 20s, 10s is 2,000, and 5s are that. So this is way off. And if we look at if that's our cash to give and our amount to return, we've got negative 326. So we've got something broken within here. Okay. Well, the first thing I'm going to do is clean this up a little bit. When we come up here, we're saying index is equal to 1. We're setting denomination, but then we're having to do all this denomination. We're duplicating this code. It's kind of ugly. So what I want to do is say money value, and that's going to be the denomination at position 1. And if we go console.log money value, I'm just going to have to comment this out for now. We'll see that that's just getting us the value. And I also want to have something called the money name. And I'm going to set the money name equal to the same thing, but the first position. So money name. Cool. So now I've got the money name and the money value. So that'll make this stuff a little bit easier. And so instead of saying denomination in position 1, I'm just going to say money value. Denomination money name. Money cash on hand. What was that? Denomination at 0. Money value. Yeah, money name. And amount to return. And then this is money name here. This is money name. And then everything where it's denominations at position 1, money value, money value, money value. Okay, so that just made it so that we basically have the same thing, but now it's a little bit easier to read. And so what's happening here? The first thing we're doing is we're trying to figure out the right amount of cash, right? So I'm going to log the money name. Log. So a 20, a 10, and a 5. 20, 10, and a 5. Yeah, that looks legit. The way that we're doing this right now, 3.26, 10. We're going to have a 20, a 10, a 5, but we're also going to have a 1, a quarter, and a dime. So something is happening maybe further up the line. Well, let's say actually we can say this too. If our amount due is equal to 0, we don't need to continue this while loop. So let's add in here, if our amount due is greater than 0, amount to return, sorry, is greater than 0, then we do that. But that didn't do anything, but that's fine. Here, what we also want to do, I think what's happening is we're having 5. We're putting 2,000 worth of 5s in there. 2,005. So it's just about right, but it stops there. So something's happening there. So I'm thinking the money value. So console money value 20, 100, 500. We're only getting to the 5s. And amount to return. So I'm console logging the amount to return. Yeah. Here, console.log our cash on hand, right? This is the thing. We want our cash on hand. That gives us just the big object. We want to make sure that we're dealing with the specific the money name. So we're seeing this 10,005. Okay, so if we want our cash on hand to be greater than the amount to return, and so that passes all the time here. So, but this is a good conditional for us to ensure that we're doing in our if statement, because we want to make sure before we enter into this situation, we have enough money on hand to deal with such a thing. So now we're getting an insufficient fund. Let's console.log. Okay, so we're still getting into here. So the POW just showed up here. I just write POW in there as a quick one to say it. It doesn't mean anything. Let's say our money. So now we've selected our money name, and it's passed in, and we should feel confident that it's coming in here. So the 100 bill is being passed in here. Let's see, our cash to give. At this point, it's blank, but we're setting it here. At this point, it's got the 100 in it. And then, are we getting into here? The 100 is getting into here. Okay, cool. Oh, okay. What we need to say is our amount to return minus the money value needs to be greater than 0. Okay, cool. So now we're getting somewhere. Insufficient funds. Weird. But you can see right here I've got a bunch of... Yeah, the result is coming out semi-correct. So we've got... we don't have 100, but we have 6 20s. So 6 20s, 2 10s, 2 10s, 5, 1 quarter. Okay, cool. Okay, we're getting closer with this one, but if you look here, you see we've got 3 pennies and we want to have 4. We don't want to have nickels. We actually don't want to have this nickel in here either, so that's a problem we're going to have to deal with. But first off, this is an off by 1 thing, so I think, yeah, our amount to return minus the money value. Yeah, what this is saying is if our amount to return is 1 penny, we want to run through with the 1 penny one more time, but because it's greater than 0, we want it to be greater than or equal to 0. And so now we're getting 4 pennies. Awesome. And that's what's happening here. So this is our cash to give object. Our cash to give object should not have this 100 or this nickel in here, because here we see we want 20, 10, 5, quarter, dime, penny. No nickel, no 100 in there. So that's going to be a problem that we need to deal with down here. Let's run the test real quick and see where we're at. Okay, so even our first test is passing with our new functionality. So I'm just going to throw our first test in there because we remember it pretty well. It's just we want to get back 2 quarters. It's a simple one. And so yeah, this is where our problem is. I'm going to get rid of this console log. It's not important for now. So this is, right now I'm just logging back our response. And our quarters is in here, but we have all this unnecessary information in here as well. So we're going to get rid of that. Okay, cool. So I'm pretty sure that what's happening here is here where we have our object keys, we're having a situation where we want to put a conditional in here. So console.log, let's say money type. So we're doing each time we're going in here, we're doing, so what we're doing right now is we're pushing onto our change array every single thing. So I think what we could do is say if our cash to give and the money type, let's see, if that's 0. Oh, cool. So we only want to record the 50. And so our cash to give, if cash to give is greater than 0. So that's going to be false, 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 and then it's only going to be true on the last element. Then we're going to want to push it on there. And if we want to push it on there, we just put this guy in here. And then we only get our quarters. Cool. So let's run the test, see what happens here. Oh, awesome. All right, so now we're done dealing with insufficient funds as well as having a status here. This is great. Okay, cool. So now this is our last test case. So here what we're doing is we're returning open, but the problem is we want to say that our cash register is closed. Okay, and so yeah, here what we're doing is we're saying we only want to do this if the register has money. So I'm going to create a little variable. I'm going to say let register is register empty, and I'm going to set that equal to true initially. So the register is set to true, and now what I want to do is check our cash on hand, right? So if I console.log our cash on hand, we're going to see everything's 0. And so what I want to do is iterate through each of these and check, because if we do one of these guys, if we go with this guy, you'll see that our result, when we console log, well, that one doesn't work because it's the insufficient fund test. This one should work. So yeah, I'm just running this test. And so I want to say if, obviously in this cash register, there's tons of money on hand, and any of these would iterate through. And so if is register empty. So what I want to do is iterate through the cash on hand. So we can do object.keys, and that gets us the cash on hand. So we've got penny, nickel, dime, quarter, 5, 10, 100. And so we can say that's the keys of our cash on hand. So because this is an array, we can iterate through it. So we can say well, now I want to get out of the console log. And so I'm going to say for each, and then I'm going to say function, and then we're going to say money type, and I'll console.log the money type. Okay. So now we're getting penny, quarter, nickel, dime. Now I want to say our cash on hand of that on the money type. Okay, so if this is greater than 0, we're testing to see if we have any cash on hand. So if this one's going to pass multiple times, as you can see, there's like 97 and a bunch, but down here, we should be getting just a big row of zeros because our cash on hand has gone to 0. So this is where we want to say that. So we want to say if our cash on hand money type is greater than 0, cash on hand money type is greater than 0, then we want to say is register empty. We want to say, instead of saying is register empty, and instead of assuming, we automatically assume it's true, but with the example where it's not, we want to say it's false. No, the register's not empty. It's full. And so now if we were to console.log, here we have what should be an register, and is register empty. Maybe we want to make it false like this and then true in here. False. Let me see, I'm going to console.log the cash on hand money type again. Okay, is register empty. Is register empty? It's false. We set it initially to false, but here oh, well maybe if it's is equal to true. No, we want to automatically assume it's false. The register is empty, and then if the cash on hand is greater than 0, then we want to say is register empty is true. Okay, so now the register empty is true. Okay, so now we can come into here. And so yeah, what we want to do is create an if statement. So what we're saying is if is register empty. I mean, if it's false, if the register is empty, which it will be for our example here, we're going to do closed thing, closed. That's not the right thing. I'm just putting it in there. If it's like that, and then else, we want to run this code up there. And so, yeah, we've got closed here, but that's not what we want. We actually just want to say closed. We want to return closed. We want to return this object, status of closed, and instead of change being whatever this is, we want to just return the CID, which we're being passed in from all the way up here. And so now, this is closed. And I tentatively think that this is solved. So I'll get rid of the console log here. Get rid of the console log here. And now we should just get that. That's closed. Okay. And so if I run the tests, looks like I broke something. Okay, cool. So let's go back to this guy. This is our initial one. We've injured our initial solution, but we're getting the last one. And so now let's see. So now we're getting closed as well here. So I think there's something wrong with our register empty. So let's console log the type. Why is cash on hand greater than 0? Is register empty? Oh, this needs to be false. False. The register is not empty. So because that's true, we set the register. If the register empty, it's false. It's not empty. So we don't return this, we return that. Cool. I think that was it. That was a typo. Awesome. Okay. That's it for now. If that's just how you guys, if you're just looking for the answer, we're done there. But I am going to refactor this a bit because this is a very challenging problem and refactoring is helpful. So let's get rid of the console log that we don't need. And now we're just going to refactor. Okay. So the first thing that I did, each time I used these like vanilla JavaScript stuff. In JavaScript ES6, we can use arrow functions. So we can slam these, we can change these guys. The denomination, math.round, keep that, denominations.length -1, amount to return. This is all good. I like that we kept the code dry here. We use money name and money value, especially since we had to repeat them so often. Is greater than here, amount to return. Actually, I don't even want to change any of that because it's quite complex and I think I kind of got it. I was working on it before, so I put a lot of effort into figuring this out, and that probably made me refactor my thinking as I was working through it. Objects out money. Here's another, we can change this guy. This is a vanilla JavaScript function. We can change that to an arrow function to tighten it up a little. Yeah, we don't want to make this a ternary operator. Yeah, because then we would, if we just had one penny missing, it wouldn't work. One thing that you might have done it initially. So if you say if register empty is equal to false, then you'd get this. This would still pass the tests, I think. Oh, wait. If register is empty is equal to true. This would still pass the tests. But in refactoring, because of implicit nature of this, is register empty renders to true. And so you don't need to say, is it equal to true? You could. It doesn't make a difference. It's a matter of taste. But using implicit returns like this is a pretty solid way to do things. And so here we can get rid of this guy, make this an arrow function, no problem. When you type is greater than 0, change push array. I mean, we could make this a ternary situation by making this a question mark. And then making this like nothing. No, I don't even know how to do that. And it's completely useless. Like, why would you do that? This basically just says if it works, push it in. We'll just leave that there. Yeah, I usually like when I write these guys, I like to separate them by spaces here. It looks like we should keep with the same convention. So if we're writing our objects in line, we should keep them in line like that. And so yeah, I think this looks a little bit cleaner. Again, this is a really challenging problem for me, so I actually did a lot of the work behind the scenes, and I tried to do it like 3 or 4 times before I could actually solve the thing. So this is a really challenging one. But yeah, it's actually, once you get it, it's probably super frustrating, especially for early stage programmers, but once you've got it done, that's a great feeling. Because when you run the tests on this one, you're 100% complete with the algorithms and data structure project. And so when you submit this, there should be, yeah, some sort of a curriculum thing. Didn't pop up for me. But that completes the entire JavaScript algorithm data structure projects. And now we're done with the whole JavaScript algorithms and data structures certification. That's a big deal. Yeah, I hope you guys enjoyed this one. This is probably one of the tougher things that you're going to deal with, and it's just a continuous building blocks, but you're really getting into really cool stuff. Pretty soon, when you're done with the front-end library certification, the API and microservices, you're going to be ready to start building web applications, which is pretty amazing. So the cool thing about learning all this stuff is it ports over to other languages, and so this is a really big accomplishment for you to have gotten through this section, and especially this one. This cache register problem is probably the toughest. It's a really great data algorithm project because you can actually see how it's useful. It makes sense why you would need a cache register sort of function like this. And yeah, I just think it's a cool thing. So congratulations for sticking it out and completing the JavaScript algorithms and data structures certification. I hope you guys enjoyed this one, and we'll see you in the next video.